Now that we've built a simple SDK to send HTTP requests to DNA Center, let's build a new site and add a dummy device. Before we dive into the code, notice that the site data directory contains 4 files, one for each type of site, plus a device file. We'll be loading these files into Python soon. Let's explore the build-sites.py script to get started. First, we import JSON to read data in from the files we just saw. Then, we import time to help with asynchronous request processing later. This last import will be common to almost every script, which pulls in the DNAC Requester SDK we reviewed in the last demo. Let's jump into the main function next. First, we instantiate the class. The host, username, and password are all supplied on the DevNet Sandbox page, as we saw in a previous demo. Because this sandbox is a private installation with self-signed SSL certificates, let's disable SSL validation by setting verify to false. There are 3 categories of sites: areas, buildings, and floors. Let's iterate over a list containing each of these strings. Then, we'll load in the data from the corresponding file names within the site data directory. We saw these earlier in the clip, but let's explore them quickly. Each file contains the exact HTTP body dictionary required in the POST request to build a given object. There are 2 keys, type and site. The type key identifies the component, which must be area, building, or floor. The site data will vary between the different types, but since area is the highest level, we only need to specify a name and a parent. Next, we specify a building as indicated by the type. This references the parent site, which is global/Maryland, and assumes the area has already been created. Other parameters like the name, address, and coordinates are less important for this demo, but are clearly useful in production environments. Last, we have the floor. This assumes that both the area and building have been created, as evidenced by the parent name value. I've supplied some dimensions in addition to a name for uniqueness. On each iteration of the loop, the data variable will be set to one of these dictionaries. I've declared a few local variables to help print a status message which indicates the type of site being added as well as the site's name. Then, we issue the POST request to the site resource and include the data dictionary as the body. Here's what the response data looks like. Unfortunately, the site API uses a different asynchronous handling mechanism than pretty much every other feature in DNA Center. We'll handle this manually by extracting the execution status URL, then writing a custom function. Here's the code that performs those steps, and notice we slice off the leading slash from the URL so that we can process the resource correctly. Let's explore the wait for site creation function quickly. The logic is very similar to the wait for task function reviewed previously, except takes in a status URL instead of a task ID. For variety, I've implemented this loop to run forever, sleeping 5 seconds in between each run by default. That means that timeouts are impossible. We'll use our rec helper function to issue a GET request to the status URL. As long as the status value is not equal to in progress, we know the task is done. Maybe it passed, maybe it failed, but we can allow the caller to figure that out. Let's just return the response data to keep it simple. Next, we can test to see if the success key has indicated success or failure. Here's an example of the response data structure. Note that the status key will always be present. If it doesn't succeed, raise a value error to indicate the failure. Let's perform a GET request on the objects we just created. These items will now have UUIDs that we may need later, and we can optionally print them to the console for troubleshooting. Here's a quick look at what the response data might look like. Specifically for floors, we'll need to capture the object ID, as we'll be associating a dummy device onto the floor later. Note that we only need to store the object ID for the floor, not the area or building, so a simple if statement works well. At this point, our site is completely built. We can now explore the device.json file, which defines a dummy device we can introduce to our new site. For those who viewed the suggested prerequisite courses, this should look familiar. It's the near minimal set of parameters required to add a new device to the DNA Center inventory. We don't need to scrub the details today. Next, let's issue the POST request to create this new device, which is an asynchronous API call. Here's how the response data is structured, and this is what a typical async response looks like. We mostly care about the task ID more than anything else. Let's extract that specific information from the response and pass it into our waitForTask function. If the task succeeds, the script will continue, and if it fails, the function will raise some kind of error. To assign devices to a floor, we can specify a list of IP addresses in the HTTP body to the device resource within the site API. Let's extract the IP address from the device JSON file, then use it in the HTTP body of the POST request. This tells DNA Center to assign devices with matching IPs to a given floor, identified by ID. The response comes back with an execution status URL, just like the site creation API responses, and we'll need to wait for the assignment to be complete before continuing. Just like last time, let's extract that URL, slice off the leading slash, and pass it in to our helper function that assists with asynchronous site API calls. Let's perform a quick sanity check by querying the membership resource for our newly created floor. We expect to see exactly one device assigned to this site, and here's an example of what the response might look like. If we assigned more devices, the list of dictionaries would be longer. Using standard dictionary and list access techniques, carefully extract the management IP address from the device. Compare that value against the expected IP address loaded from the JSON file. If they don't match, something has gone horribly wrong, so raise a value error and reveal the mismatched IPs. Assuming everything worked, let's print a final status message that confirms the new device was assigned to the specific floor. Okay, I know that was a lot of code. Let's clear the screen before continuing. Finally, it's time to run our script using the Python command shown. For each site object, we see a status message indicating a new addition, plus the object ID. First, we build the area, then the building in that area, then the floor in that building. Last, the script prints a status message indicating that a new device was added to the new floor. We won't do much in the DNA Center web interface, but here's a screenshot that shows the final result. This is another way to confirm that the area, building, floor, and dummy device were all organized correctly. Coming up next, let's discuss network discoveries.